Okay, these are the problems you have on the document. I'm going to show my paper. I'll use my notebook paper, but you're going to need some pictures to see. So these are pretty basic, and you're going to use your ABC button quite a bit. In order for business forms that require 7 ruled columns as received by a printing shop, a printer lays out columns of the following widths: 5/8 inches, 2 2/3 inches, 3.5 inches, 1 17/32 inches, 1 1/16 inches, 2 2/3 inches. Part A, round each width to the nearest inch and estimate the total width of a spreadsheet required for each job. Total means you're adding, but you got to round on part A. 5/8, half of 8's 4, that's over 4, so 1. Half of 3 is 1.5, 2's over 3, so 2 2/3 rounds to 3. 3.5 automatically rounds to 4. 1 17/32, so half of 32 is 16. 17's more than that, so that goes to 2. 1 1/16 stays 1, that's obvious. 2 2/3 goes to 3. So I add those up, I get 13. Now part B, I just simply go through and add the actual amounts, okay? What width sheets, okay? 5/8 plus 2 2/3 plus 3 1/2 plus 1 17/32 plus 1 1/16 plus 2 2/3. That's 11 5/96 inches. Label them 2. Okay, number 2, easy problem. Find the material requirements for production run of oak chairs. An estimator finds the length of stock required for the chair legs shown. I misspelled chair. Find the total length. Okay, total length, you're just taking 2 plus 3/16 plus 5/8 plus 9/32 plus 3 1/16 plus 3/4 plus 2 7/8 plus 5/8 plus 5. Obviously, by the way, the common denominator for all that's 32 in case you're wondering, but if we ABC, we get 15 and 13/32. Common denominator 32, then I'd add up rewrite all the fractions, add the whole numbers, add the fractions, and put my fraction into simplest terms and go for it, okay? That video is going to take forever if I do that, though, okay? Wiring job calls for 5 pieces of 3/4 inch conduit. Conduit's the thickness of it. It has no bearing on the actual length. Of the following lengths: 8.5 feet, 5 3/4 feet, 3.5 feet, 5 6 feet, 3 5/8 feet, 6 1/4 feet. Part A. Run the length of each piece to the nearest foot. Add the approximate total length of the pieces needed for the job. Okay, so 8.5 goes to 9. 5 3/4, half of 4 is 2, that's going to be 6. 3.5 goes to 4. 5 6, that goes to 1, because half of 6 is 3. 5's more than 3. 3 5/8, 5/8 is over half, so that's going to be 4. 1/4 would stay at 6, okay? So I add those up together, and that is going to be my answer. So 15, 19, 20, 24, 30. 30 feet. Okay, now you add up all the actual amounts, okay? The fractions as they are. FYI, the common denominator for all of them would be 24, and I would add all of them, and it ends up as 20 5/16, ABC, okay? Calculate, so. Okay, 4 is kind of weird at the end. There's an A, there's a B, there's a C. Mike needs 4 strips of fiber in the following lengths: 5.5, 6 3/8, 2 1/16, and 5 7/8 inches. Round each length of strip to the nearest inch and add to find the approximate total length strips are needed. So 5.5 goes to 6, 6 3/8, that would stay 6. 2 1/16 stays 2, 5 7/8 goes to 6, so that's 12, 14, 20. 20 inches. Part B, determine the actual length. Now you just add them with the fractions, okay? If you're interested, the common denominator for 2, 8, 16, 8 would be 16, but if we ABC it, we get 19 and 13/16. Now part C is kind of weird. It teaches you kind of about what to do. When you're cutting something, I don't care what it is, fiber, whatever, you're going to have waste left over every time you cut it. Because you're going to cut a piece that you need, then there's going to be a piece left over that's completely worthless, okay? Which is added on to what you need, okay? What's the shortest strip of fiber that can be used if 1/8 of an inch is allowed for each saw cut, okay? So you take that 19 and 13/16, but then every time I make the cut, I have to add 1/8 of an inch, and I made how many cuts? 1, 2, 3, 4. So I would multiply that by 4, okay? 19 and 13/16 plus 1/8 times 4, okay? Because every time I make a cut, there's 1/8 of an inch that I have to use that I throw away, okay? So I have to add 1/8 of an inch, but I cut 4 times. So 1/8 times 4 is 1/2. Then add 19 and 13/16 to 1/2, and you get 20 and 5/16. And that's going to come up from time to time, the waste. The waste gets added on to what you need, okay? Even though you don't need it, you're going to throw it away. You have to account for it, okay? It's called accounting for waste, okay? So what I need, I have to add waste on, okay? 1/8 times 4, because it's for every cut. Okay, number 5. Determine in inches the dimensions of A, B, C of the steel base plate shown. Looks like an intimidating problem, but it's really not. Because, I mean, I look at part A, which is right here. I know the 3 inner parts, 1/4 plus 1 7/16 plus 19/32. I add those together and I get 2 9/32. Common denominator is 32 in case you're wondering. Okay, B. And you see like 4, 16, 32, 64, because those are your measurements on a ruler, okay? That's why a metric ruler. B, the 2 inner parts, 2 1/64 plus 1 27/32. And that's 33 and 55 over 64. Common denominator would be 64, FYI. Okay, C. Well, let's just take our answer from B rather than re-add these, which we already know the answer for. Let's take that 3 and 55/64 and add just this little part here from here to here to be 3/8. That's 14 and 60 and 4 and 15 over 64. FYI, common denominator is 64 in case you're wondering. But you end up with an improper fraction, so that's why the 3 became a 4. Okay, number 6. In finishing the interior trim of a building, a carpenter measures and saws a length of molding in 3 pieces, as shown. Determine the actual length of the 3rd piece. Okay, the whole thing's 44 and 1/2, but we need to minus from that to find this. And I minus the sum of 14 and 5/32 plus 1/16 plus 11 and 7/8 plus 1/16. Okay, you got to account for those little pieces in between. Okay, so I would first add the amounts, the inner amounts that I know. FYI, common denominator for 32, 16, 8, 16 is 32. Okay, so I got 26 and 5/32 when I added them all. Then I'm going to entertain myself here. You can ABC that. I'll get a common denominator is 32. So 2 times 16 is 32. 1 times 16 is 16. So it's going to be 18 and 11/32. That minus that, the whole numbers, I can minus the fractions, 11 over 16. Again, use ABC to make it go a little quicker. Okay. So that was number 6. Okay. Okay, number 7. baker mixes a batch of dough that weighs 120 pounds. The dough consists of 40 3/4 pounds of flour, 5 pounds of salt, 2 1/4 pounds of sugar, 3 1/2 pounds of that doesn't make any sense. Get rid of the sugar. We're going to call that vinegar. Okay. I don't think you need 3 1/2 pounds of it, but we'll say we do. Okay. 3 1/2 pounds of vinegar because we already have the sugar here. 1 1/4 pounds of malt, 4 1/4 pounds of shortening, and water. How much water is in the batch? Okay, so the whole batch is 120. And then the water I would subtract, but then I have to find the sum of 40 3/4 plus 5 plus 2 1/4 plus 3 1/2 plus 1 1/4 plus 4 1/4. Okay. 4, 4, 2, 4, 4. The common denominator is 4, FYI. So I would add those all together. And I get 57. Okay. So 120 minus 57, 63. 63 pounds of water. That's a lot of water. Okay. Okay, 8's an easy problem. Okay, a bolt of woolen cloth is shrunk before a garment maker uses it. Before the shrinking, the bolt measures 13 1/3 yards long and 1/4 yard wide. The material shrinks 1/4 yard in length and 1/16 yard in width. Find the length after shrinking, where you're just going to subtract, okay? 13 1/3 minus 1/4. Okay, 13 over. It's going to be 13 1/12. And then find the width after shrinking. You take the 1/4 minus 1/16. FYI, common denominator would be 16, 4 times 4, 1 times 4, ends up as 13/16. I'm doing a crappy job of labeling. Number 6, the label's pounds, and then yards and yards. Okay, not labeling my answers very well. Okay, number 9. Find the inches in this diagram of F, G, H, and I. I wouldn't need to label these because I don't know the label. Okay, so it's not hard. F's here. Let's find a 2 1/16 minus 1 3/8. That ends up as 11/16. Okay. Letter G, well, G's here to here. We got this part outside, 2 1/3, and then this other part's 13 over 16. 2 1/3, or 2 1/32. It's 1/32. 2 1/32 minus 13/16. Okay. Then I subtract, that's 7/32. Wait a second, I don't think I did that right. Okay. 1 7/32, sorry. 1 7/32. Okay, letter H, 1 1/2 minus 1 1/64. Okay, subtract those two and you're going to get 31/64 of an inch. Okay, almost a ½ inch, but not quite. Okay, then I go find letter I. Okay. I is from here to here, so I know right beside it's 2 1/8. Now the outside part's 2 47/64, so I take 2 47/64 minus the 2 1/8. That gives me 2 39/64. Okay. Okay, number 10. Number 10, you got to do some thinking here. You're not just going to add them all up. What you see, okay? A plumber's piping plan is shown consists of 6 copper pipes and 7 fittings. Now here's the key part. Both ends of each pipe are threaded 1/2 inch into the fittings. So there's a 1/2 inch, so these are your fittings here, okay, here to here. But, or sorry, my bad. This is a pipe, and then these little things that stick out with the little rings, that's a fitting. But there's 1/2 of an inch that you don't see wedged in there, and then 1/2 inch on the other side, so remember that. Find an inch is the total length of the 6 pipes needed for the plan, okay? So what I'm going to do is add up all the pipe parts that I see, okay? So 23 and, anyway, adds up, I'll tell you what it adds up to. You don't want to probably watch me punch numbers into the calculator. Adds up to 79, 11, 30 seconds, but you got to now account for those pieces wedged in that you don't see. So it says they're 1/2 of an inch, okay? Now we got to count how many 1/2 inches that would be. So this weighs 1, this weighs 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, because it goes both ways. 1/2 times 12 is 6. 79 plus 6 then is 85. 85 and 11, 30 seconds. So again, that's why it's important to read that. 11's easy. Okay, sheet metal technician shears 4 pieces from a 50-inch length of sheet steel. The lengths of the sheared pieces are 3 3/4 inches, 9 3/4 inches, 4 1/4 inch, and 9 5/8 of an inch. What's the length of sheet steel left after all the pieces are sheared? So we take 50 minus the sum of 3 3/4 plus 9 3/4. I'm just adding what I'm cutting. 4 1/4 plus 9 5/8. Okay. So I figure all that out. Okay. In the fraction, FYI, the common denominator would be 8. Okay. 3 3/4 plus 9 3/4 plus 4 1/4 plus 9 5/8. Okay. 27 3/8. Then I can minus that. Okay, that's 22 5/8 when I subtract. Number 12, example 12. 3 views of a machine part are drawn by a drafter as shown. Okay, it looks really confusing. A 2.5 inch margin. So these margins, wherever it says margin, that's 2.5 inches. Okay. From each of the 4 edges of the sheet of paper allowed, find the distance of X. So X from here to here, distance X. So from the margins 2, so part A, X. So our margin is 2 1/2, okay? Plus 1 9/16, plus 3 13 30 plus 1 63 64, plus 2, plus 3 1/2, okay? 14 61 64. Then part B, there's a distance Y we need to find, okay? So Y, that's 2.5. The margin is. So we go 2.5 plus 1 17 30 plus 2 5/16 plus 2. Now Y keeps going, so I look over here. Plus 3 3/64 plus 29 64. Common denominator there would be 64. Okay, 11 27 30. And that's your Y. Okay, next one talks about electricity. And it says, in a series circuit, the total resistance is the sum of the individual resistances. What resistance must be placed in a series circuit with 13 1/8 ohms of resistance in order to have a total resistance of 22 3/5 ohms of resistance? Now, I know you guys might not know a lot about electricity, but look, they give me the total, and then they give me one of the circuits. They want to know what the other circuit would be to make that total. Well, that's easy. We would just subtract, okay? 22 3/5 minus 13 1/8. Okay, and that gives you the other circuit to make that total. It's 9 and 19/40. Common denominator of 5 and 8 is 40. Okay, number 14. Number 14 is kind of a tricky one. Okay, a cable is 12 feet 4 1/4 inches long. It's to be cut into 6 3/8 inch lengths. Allow 1/16 inch waste for each saw cut. Okay, so every piece is 6 3/8, but then along with that, I take another piece with it, the 1/16 that I have to throw away after I get done cutting it. Part A, how many 6 3/8 inch pieces can be made? Well, this is going to be a problem, a rare problem where division's needed, because we need to take our 12 feet 4 1/4 inches divided by, I'm making a parentheses for a reason. It's not just 6 3/8, because remember, I have to add a 1/16 of an inch along with every cut I make. Okay, couple things we have to do to figure this out. First off, we got to get everything in inches. Okay, 6 3/8 in inches, 1/16 in inches, 4 1/4 in inches, but 12 feet's not. Well, since there's 12 inches in a foot, I can simply take 12 times 12, because 12 inches in a foot, that's 144 inches. Then I add the 4 to that, that's 148 1/4 inches. So I take 148 1/4 inches divided by, and then remember, every piece is 6 3/8 that I need to cut and use, but I also have to add the waste onto it. So 6 3/8 plus 1/16, 6 7/16. Now remember that each one I use, I have to use 6/78, so I divide those two. Now I can't do that as a piece. You can only get 23 pieces, so that's the answer, 23 pieces. Again, I'm not labeling on this. That should be ohms up there. Okay. Okay, so again, you take what you start with divided by the sum of what your piece are plus your length. Now make sure you know what that is, 6 7/16, and you got to convert your feet to inches and then add the inches onto that. Part B, how many feet are left? That should say how many inches, my bad. I need to change that on the document too. How many inches, okay, will be left over? What'd you start with? You started with 148 1/4 inches, okay? Minus, okay, obviously to figure out the leftover, minus 6 7/16, because remember you got to include after you've added the waste, and you have just cut 23 of those, so times 23, okay? So you take every piece, remember, along with its waste, okay, find the product, 7/16, multiply by how many pieces you just cut, and that's how much was removed, 148 1/16. Then I subtract, okay? It's 3/16, okay? You got a common denominator, it'd be 16. So again, let me run through that again. How many pieces cut? Well, you're gonna have to divide, okay? So you take your beginning amount divided by what you're cutting, but remember to add that onto the cut, the waste. So then I need to convert the feet to inches and add the inches on, 148 1/4 divided by the sum of the piece and the waste, okay? So I got 23 and something, so 23 pieces. Now again, the leftover, take your 148 1/4 inches minus how many pieces you cut, 23, times what every piece needs, which is not 6 3/8, it's 6 7/16. Okay. Okay, 15's easy. In estimating labor costs for a job, a bricklayer figures a total of 52 hours. The job takes longer to complete than estimated. The hours worked are as follows: 6.5, 10 3/4, 11, 13.5, 9 3/4, 10 3/4. By how many hours was this job underestimated? Okay. Well, when you add the actual time it took, it's 62 1/4. Well, we thought it was only going to take 52. It was underestimated by 10 1/4 hours. Or 10 hours, 15 minutes, because a quarter of an hour is 15 minutes. Okay. Number 17, last one. I skipped 16 for whatever reason. Okay. An offset duplicator operator prints forms and other material required by a company. In planning for 3 duplicate orders, the operator estimates the paper required. 4 different types of bond paper are needed to print the 3 orders as shown in the table, also shown as the paper on hand. Substance 16, it's called the type of paper. Okay. So we need that many reams for order 1, that many for order 2, that many for order 3. Now we already have this stored in a closet somewhere. Okay. So find the total reams of each type of paper required to complete the 3 orders. So A, I got to find 16, substance 16, substance 20, substance 24, substance 28. Well, it's not hard to find out how much you need to order. You just add 2.5 plus 0 plus 5 1/8. Okay, that's 7 5/8. Substance 20, 16 2/3. That could be easy mental math. 3/4 plus 2.5 plus 1/2, that is going to be 3 3/4 of a ream. And those two added together is 10 1/6. So that's it for part A, how much you need. Part B, how many additional reams of each type must be ordered? So again, 16, 20, 24, 28. So I need to order 7 5/8, but I've already got the 6 2/3 on hand. So I just take 7 5/8 minus 6 2/3, and that's going to give me 23 24. Put the fraction. I know that's pretty close to 1, but okay. We need 16 2/3 of substance 20, but I've got 10 reams on hand in the closet. So 16 2/3 minus 10 is 6 2/3. Okay, 3 3/4 reams are needed for substance 24, but I got 1 1/2 in the closet. Okay, so I subtract those and I get 2 1/4. Then finally, I need 10 1/6 reams of substance 28 paper, but I have 7 3/4 on hand. So 10 1/6 minus 7 3/4 equals 2 5/12.